Hello, BP Car Audio back. Second part of this Rockford Fosgate Punch 401S rebuild. This is a plastic torch. It uses hot air. This is what we're going to use to take these transistors off. And we got the parts in here. Got a few parts there. Those are the transistors. I got some resistors right here. We're going to heat this baby up and see if we can get some transistors off of here. Let's see what kind of temperature we got going on here. Yeah, we're getting up to about 200 and some degrees, looks like. So, she's getting hot. Basically what you do is you just work this on the back side of the heatsink here, the torch. This uses compressed air and electricity. It's pretty neat. The compressor's in the garage, so we don't have a bunch of noise, and there's a regulator on the floor regulating the power to it. And I think I have a light tripping. I don't know what the heck it's doing. Anyway, you just kind of work on these a little bit and heat and check with the thermo gauge here. Looks like we're about, oh, it's climbing still. It's getting there. Right around 500 degrees when this stuff starts melting. So we'll heat the bottom side for a while, and sometimes I even take the soldering iron and put it on the top side here. So we may have to do that with this. I'm not sure. This thing takes a while though. You gotta be careful with doing this though, because you don't want to pull the foil off the board. So we'll do it on the top here for a while. Just like a hot air rework station, the way this thing works. It's actually for doing plastic, like I said in the beginning, but it works really, really well to do these surface mount components like this. You could do the same thing with a heat gun. This is what I have, so that's what I use. You just kind of use a screwdriver like a, like a spatula. I need some more air here. Hang on. There we go. I've taken these off before with a soldering iron. Basically, you just get you put flux on here, put some solder on it, get the whole thing hot, and then pry them off. But you run the risk of pulling that copper with it, so we'll do it this way. And I'll show you guys the first one, and then I'll go ahead and remove the other ones off camera. And then we'll put the BIOS resistors in, power it up, and see if it works. Maybe. It might start being in there. It takes quite a while to get these warm. So Yeah, they haven't even got that hot yet. Only about 100 some degrees. So it does take a while. Looks like the flux is bubbling here around these. And that temperature gauge might be off, so anything's possible. This one's starting to lift. So we'll just, there you go. See, just like that. That's all that holds those things on. A little bit of solder there. We'll go ahead and work the rest of these off, since they're getting pretty hot and malleable. Basically, you just work it back and forth like that until you can see an edge start to pop up here. And I'm going to go back with more solder than what was on here because I'm not that clean of a perfectionist. It really helps to put the heat on the bottom because that's where the transfer is of the heat itself. It actually works better than doing the top. So, but we got lucky with this one. The camera off. This thing does get pretty hot. The handle gets pretty hot anyway. You just work that around there until it starts to lift, and then you just pull her off like that. Works really well. There we go. That was my finger I just burnt the crap out of. Look at that. That'll teach me, huh? Okay, that's all of those off, and you gotta be careful because this is heating up the whole thing. So yeah, this is it's a Harbor Freight plastic welder is what this is. Alrighty, I'm gonna turn you off and we'll come back and when we put the new ones on. Alrighty, well, we've got all of the devices off of the board here. Ouch, this thing's still hot. Got all of them off here. Got the resistors out, and all the devices on this side, and the resistors out. Thank goodness I didn't unsolder the power supplies. They're still intact. It's still cooling off in the background. That thing takes quite a while to cool off. So, anyway, let's get this out of the way. And this out of the way for the moment. And here's all the transistors out of it. And also, I've got the resistors too. This is the only good one left out of all of them. And I will show you that here in just a few minutes. And, oops, I dropped one. Anyway. There's all the bad ones. They're quite crispy fried. And I'll also show you guys that with the meter. I don't know where that, there it is, where that one went. Yeah, look at that damage. It's beautiful. Big hole in it. Alrighty, so first, let's get out the transistors and check them here with the old Harbor Freight heater. Fun. Turn her on there. We got her on ohms. We'll put her on diode check. That way when we hit the deals here, it'll zero out. That's how much resistance is in my cables here. Not much. These are MOSFETs. And basically, yeah, it should read something like that on one side. This is probably the good one. The center's obviously hooked to the tab. And you change position. Can't see what I'm doing here. Put your negative on top and check here. And there'll be 1,000 something. No connection on that one. And that may be, I'm should be a diode in there too. So this one may be halfway dead. So yeah. Yeah, because we're not getting anything. This way we're getting 0.832. Nothing there. Nothing there. Okay, we'll set that one off to the side. That one's shorted. Shorted. And we'll do this way. Shorted. And shorted. So this one is definitely shorted, like welded together inside. It takes a lot of power to do that. And there's that little piece of wire that I saw a while back in that video that I took. So that one's shorted. Shorted. You gotta make sure you check them both ways. 102. 0.033. And that's what was causing that one channel to put out 30 some volts across the speaker terminals. Shorted. Shorted. Oh, that one shorted good. 0.004, 002. Ah, yeah. That one's dang near a straight through connection. Nothing there. 0.867 ohms. Nothing. A 1067. There's actually a diode in between the center pin and the right pin here. And what that does is it causes the it's kind of like a check valve, one-way check valve. Your power can only go one way but not back through the other way. So, ah yeah, shorted. Good and shorted. 0.3 and 0.2. Awesome. I'm starting to see a trend here. These are definitely dead. But since we have them out of the board, now you can actually test them for real. I mean, I had a pretty good instigation that it might have been shorted from the beginning, but yeah, 0.002, 0.004, and our leads are 0.002. So that one is definitely shorted too. This one, I'm not sure. Like I said, 0.82221. That would be that diode, I'm pretty sure, that's in there. Because if we reverse the polarity, yeah, it's open. This is the gate that opens the transistor up. MOSFET. You go between the input and the output, nothing. Yeah. So they may still have been bad, even though they're not completely shorted. Okay, just for giggles. Brand new part. Let's check out what a brand new part looks like. I know some of you are realizing, and I am too at this point, I don't remember which ones went where. Thank goodness I took pictures. Okay, this would be the drain to the outside. You got 0.555, base, nothing. Or I guess that would be the gate, sorry. 0.555, and we got a 1.258 across the drain, the gate, drain, and source, and nothing across the input. So this particular MOSFET, you're not going to have any kind of resistance across between the gate and these two legs here, because they're this is actually where the magic happens, is on these two legs, and this one, all it does is provides an opening, opens a valve. So these two, you're going to have a little bit of resistance. And, okay, So that's a little bit of information on those. Okay, resistors. Here we go. Okay, I wasn't quite sure exactly what wattage these were. I've read everything between 1 watt and like 4 watts, because I have a 5 watt resistor around here, and I knew it wasn't a 5 watt because here's what a 5 watt resistor looks like. And quite a difference in size. So I knew it wasn't a 5 watt. I bought these for another amplifier. So these are 2 watt resistors. Right there, 2W. I don't know if you can see it or not. And the ohmage was 0.10 ohms. And I bought extras just in case. I think this was the good one. Let's see here. Yeah. Maybe not. Maybe this isn't the good one. Should be. Maybe not. Hello, welcome back. It looks like we ran out of space there on the old memory card. Anyway, I'm going to show you guys. I couldn't get my other meter to work right, and I was kind of skeptical of the parts there. And I use this program right here, ADITR. It's a resistor program. You figure out what the colors are. These have little color bands on them. This one's hard to see. It's brown, black, silver, gold tolerance. So we go brown, black, you go down here to silver, which will either be that one or that one. Yeah, it's that one. With a gold tolerance. And there's your resistance right there. 0.01. And it's 5%, so it can be either so that'd be 6 positive or 6 below on the tolerance. And I looked at the old one here, and is this thing in the right mode? That puts it at 0.7, so that'd be about right with 5% tolerance. And then I looked at one of the new ones here. Like I said, I looked these up on the internet and made sure they were right, and here we are, 0.6. So they should work. These are carbon film resistors, and I think these are too, if I remember right. If not, they're not wire wound. Maybe they are. Anyway, they're a different type of resistor than the ones that were in there. So, it should work just fine. The resistance is all you really care about, and the wattage too. So, anyway, while I waited for the video to offload off of the memory card, I went through and worked on cleaning up some of these holes. Here where the transistors were and the resistors were. So we can go ahead and get the new parts in here. And I did look through the pictures. I got one of them back here in the background up. And this thing. Figured out which one goes where. So I'm going to go ahead and get these installed through the board and figure out where to bend the legs, because these had kind of a bend to them. And looks like it's right here. Slide over here a little bit. It looks like it's right here at the transition. I know this camera isn't the greatest for this, but there's a transition right here, and it looks like that's where they're bent to go through the board. So with that, we shall return, and I will show you guys how to solder these on the back plane. At least the way I do it. It's probably, there's no real right way to do it. Just make sure that they solder on the back of there and they're permanent. Alright, well, we'll get these transistors put through the board, and I'll show you how to solder them onto the, what do they call this? The thermal management system. Alrighty, well, I got one of them mounted here. Sorry I didn't do that on camera, but I'll show you how to do this, and then I'm going to do the rest of them off camera. It's kind of a long, tedious process. This is the magic secret stuff. That's flux. You've already got solder on the pads here. And you take you some flux, and you just coat her up like this. Not too much, but enough to make it stick. Okay, so we got some flux on there. It's all ready to go. Go ahead and put it in the board here, through the holes. Just set her on there like that. And get our torch out. And we start heating it. Whoa. Sorry about that. Earthquake action there. You just start heating the bottom side here. And this is a lot where you go ahead and do the top. You turn up the air a little. You do the top with the air gun. Just like this, and then you come in with your soldering iron on top, heat it from both sides. Now the flux is activating, and it'll clean the surface of the back of the transistor, and the solder that's on the thermal pad there will become liquid, and then the whole thing will just kind of stick together when it's ready. Soldering iron is just adding extra heat, that's all it's doing. From the top. Come on, there we go. And you'll see this flux start to bubble and go on here along the side of the transistor, and then the solder kind of squishes out a little, like it is there. Take your heat away. Check your alignment, and you're pretty much done with that. I did this one here. Turn that off. I did this one here, but it's not completely stuck down, so we will have to reheat it again. And I'm going to use the back of this paintbrush to hold it down so it gets a better seat. But this one's there. It's stuck on there. So just go ahead and heat this up again. We'll heat it from the top. And the little hole here in the middle gives you a pretty good indication of where you're at. See? So just heat this. And then we'll work on putting some pressure downward on this to hold it in place. And I'll go ahead and grab the other iron here, the soldering iron. It's a 40 watt from the Rat Shack that died. So we'll go ahead and put this on the tab here on the top, and it's came loose. You just kind of work that thing around like that. Okay, let me grab that paintbrush handle. We'll make sure and seat it. Take heat off. Solder melts at about anywhere between 500 and 600 degrees. It just depends on the type of solder, how much mass you got. so forth, so on. Of course, my paintbrush is stuck to it. There we go. It sure was hot. And you just let that cool, and then we'll check the fitment here. Looks like they're buried nicely. And then go on to the next couple, and we'll do the same thing on the other side. I'll bring you guys back in once I've got all the transistors put in, and then we'll put in the resistors. Alright, we got all of the transistors beautifully mounted in there. Yeah, they're beautiful, aren't they? Let's see if we can get these resistors in here. Now, I went over the board and I've cleaned all the holes out, so that took a while. And basically, I just go just like this. In fact, you can put them either way, it doesn't matter. Resistors are not polarity dependent, but we will put them in here the way the board shows, with the fat end that way on those two, and the fat end this way. I can get through there on those two. Come on. There we go. And fat end that way on that one. We'll have to clip these leads, and that's just a given. Parts pretty much come in a certain length, and then you just trim them afterwards. See there, we'll have to trim those. So, no big deal. Alright, and then we got 4 on the other side here. I just go in like so. There we go. Ooh, dropped that one, didn't I? It happens. Guess there wasn't power to it. Oh, that one seems to be a little stiff. We'll have to get the soldering iron and heat that up a little bit and get it through there. And that one there, just like that. I don't know, maybe I can get it through there. We'll see. Just spin it around. There we go. Went right on in. Sometimes you can work them in there. And we'll put that side in. Voila! They're beautiful. Now we'll flip the board over and put a little solder on them. Hopefully they don't fall out like that one did. We'll go ahead and do this one side first, and then we'll do the other side. I'm using some 6040 solder here, rosin core flux. That's what's all over the board there too. I found that flux is your friend when you're working on these amplifiers. It makes it work a heck of a lot better. Let me get that straight. Yes, okay. It just makes everything work better. The flux is a cleaner, so it helps the solder stick to everything, and it's kind of like using soap when you wash, you wash stuff off, and makes it clean and works better. I'm going to have to trim these, of course. That was one. Like I showed you guys in the previous part there, they're the same resistance. The design of the resistor is a little different. These look like, if I remember right, these were a higher temperature rating, which from the looks of this amplifier may benefit from. Don't quote me on that, but that's what I'm going to guess. So, I generally try and solder the back leg here first, and then put it up right like that. Then we can solder the other side. Just like that. And of course, like I said, I'll have to trim these. No big deal. Okay, let's flip this around. And we'll get the other side put together here. I'm going to go ahead and solder this one first, this one that wants to fall out. And hopefully we won't have to worry about it falling out anymore. There we go. Get this one. I really enjoy doing this. This is almost like doing a puzzle for me, so I really enjoy it. I know some people probably be frustrated by doing this, but I really enjoy it. Ooh, come on. Get in there. There we go. That's crooked. I don't know, I kind of like to have them straight too. It doesn't really affect the way the parts work, so it's just really good for showmanship. You know, when somebody opens the amplifier again, and you guys saw the way the transistors look. They look almost like they were done in the factory. So you don't want to use too much solder, otherwise it creates a blob, and these resistors actually get kind of warm, so they could have the solder come off, and you can actually short out in there somewhere on the board, or you could blow up the power supply, which is over here on the other side. So yeah, that looks pretty good. A couple of these are not exactly straight, but just kind of work them around there. There. That looks beautiful. Like it should. Alright, well, I'm going to shut the camera off at the moment here. We'll pause it, and then I'm actually going to get the wire cutters out and trim all the leads off. You even need to trim the transistor leads. And then we'll take the meter and check everything, see if anything's shorted. It shouldn't be, but you never know. And I'll check it under the magnifier. Well, I changed my mind. We're gonna trim these on camera. I can't find my flush cut cutters, but these will work. I have a pair of really nice flush cut wire cutters, and they get a little closer, and you don't have to wiggle it off when you trim it. It just snaps right off, which is kind of nice. And we'll have to get these too. That way they don't short out on the heatsink, because the way this is designed, it's pretty shallow right there. Back to my... I don't think the solder is going to be an issue, but it could be. The soldering job. And that's where the flush cut wire cutters are really nice. You can get in here really close, and you don't have to worry about your height on the cutters there. They just get right down there close to the board and just snip it right off. And these are a little bit dull, so they're not wanting to exactly cut it smoothly. There we go. A little sharper, a little further in. I think that'll work. That's about the same depth as everything else. And we'll do this side. Oh wow, yeah, they are a lot sharper in further. Clip it right off. There's a piece that's stuck. These little pieces here, They're really good for doing projects, little jumper wires, so I save those. And the littler ones I throw away, but these are a nice size for project. You need a wire to jump or something. So, yeah, just fling it. Yeah. I'm gonna have to find out where those went. We'll get all these trimmed off, and then we'll give it a test. Well, we won't test it quite yet. I'm gonna get the meter out and check everything, make sure nothing else is shorted. I mean, I do have a little bit extra stock because of the way the ordering worked, but I don't think I have enough in case it blows up again to replace it. I don't for the resistors anyway. The transistors, yeah, I probably have enough of those to rebuild it again if I need to. Yeah, there we go. So they're all trimmed off, and we'll get some denatured alcohol and clean this mess up. That's just the solder flux. It looks really bad, but yeah, it's pretty. Other than those resistors, I mean, you wouldn't know if you looked at it if that was stock or not. Anyway, let me grab the denatured alcohol and clean that up, and I'll bring you guys back in and we'll do a resistance check. Alright, we're back with this here Rockford Fosgate amp, and I got as much of the flux off as I could. I actually think I burned some of it to the board here on the back side. I was looking here at the bottom. It's kind of toasty looking. So I probably actually burned the flux to the board. It doesn't hurt it any, it just looks really ugly. That and the board's kind of rough right there, so. But I got most of it off, and I also gave it a good bath with this stuff here. You find that in the automotive section. It takes a lot of the goo and dirt and residue off, and then I used some alcohol too. A little bit of stuff there still. Anyway, we're going to go over this with the ohm meter and check it out and see what kind of difference we have now from before. If you go back and look at the first video, 90% of this was shorted, so it should be quite a difference. Alright, we'll start here. There should be, yeah. You guys can't see that. Of course not. You see that? No, because of the angle it's at. Okay. So there we have 0.000, because it's probably the one that goes through this resistor, or not. Okay, so we got 0.4789, somewhere around there. And that might be because it's charging too. Of course, that's the center pin. I don't know why that's showing shorted. Maybe the direction. Or we have more problems, one or the other. Which one is that? Is it this one? Wow. Anyway, we'll figure it out here. Well, that must be the output pin. Okay, got 0.47. There's a capacitor in there charging. And it'll just charge until it quits, pretty much. Alrighty. Well, let's see what we got here. Shouldn't be showing that, I wouldn't think. Unless they're all on the same source. That's possible. So I'm not really sure on how this amp is designed as far as the way Fosgate designed it. And there's some capacitors in here. There's a capacitor here. There's some on the board and stuff. I say we go for it. Just put some power on this thing and see what happens. Alright, let me get some power hooked to it, and we'll see what kind of heat dissipation we have on each side, and that'll tell us a lot about it. Alright, we have some power hooked. Okay, so the battery gave up and it died. This thing gives you no warning, I swear, sometimes. Anyway, we're going to give this thing some power and see what it does. Well, nothing yet. Let me check temperatures. Oh, feels good. I say we hook speakers to it. It's crazy. Because something would have happened, it would have popped about then. So, no crazy smoke, no craziness. So, I know I don't have the lights on this thing, but yeah, nothing. Feels good. So we'll get a pair of speakers here. Well, actually first, before we go too crazy, let's do the voltage test on the outputs. Okay, so this will be test on this here channel. And technically, we shouldn't have anything, or very little, voltage at all when we power it. Power's here. There we go. Nothing. In this channel. Oh boy. We got more wrong with that one still. Okay. So, I suspect we have a driver bad. Is what I'm going to suspect, if that one is still doing stupid. Or we got something wrong. It's probably one of these, I'm guessing. But, for giggles, we are going to hook a speaker to it. And see if it makes noise. It probably will. Probably work just fine. At least on this side it will. I'm just sticking these in here, testing purposes. I can get them to stay. Or not. Alright then. We'll do the negative on this side then. Since they don't want to stay. Let's see what kind of pop we get when it turns on. So far, no crazy noise. Good. And I'm going to suspect the other side makes... Yep, I was afraid of that. Okay. Well, we're going to dive into this a little deeper. Okay, so I hooked it up, and the one channel that's not putting out voltage kind of works. I think there's something else wrong down here in the driver section. Because if you flex the board a little, it comes and goes. We still had 30 some volts on this side. Yeah, which means something else is wrong. I'll find it eventually. And then it fell off the bench and we smoked a couple of the new resistors. And these two devices are now shorted. So, I'm kind of wondering if they were shorted to begin with. So, I'm going to end this video here for tonight, and we'll pick back up on it soon. I'd like to thank everybody for watching. If you're not subscribed, get subscribed. And if you didn't like it, thumbs down. If you liked it, great. Comment if you'd like to down below. And once you're subscribed, next to the subscribe button should be a little bell icon. It's not a gear. I've been saying gear all along. It's a little bell icon, and that will notify you when I put out new videos. Anyway, this is Sean with BP Car Audio, and we'll try and figure out what other damage there is to this Fosgate amp on a later date. Anyway, thanks.